Okay, so now what we're going to do is pivot into the ThreatX dashboard. So what you're seeing here is the main attack dashboard home screen for all users. What you can see at the top here is all trending metrics that are happening over time. So what is the traffic that's going on that is seen within my environment, and what percent or what of those requests are actually being blocked? As I scroll down, what you'll notice is all these different entries that are showing all the different types of attacks that ThreatX has monitored and detected. What you notice is in the first column, we have something called a threat entity name. As you can see, what we do is highlight and classify every single attack with a classification or an entity. Here in this case, Sweltering Avery is actually Nick. And we can tell because a couple different things. One, his IP address. Nick is actually calling in and performing these attacks from Canada. So this is actually Nick's IP address right here. And in addition to this, if I scroll over to the rules, I can actually see that SQL injection attack rule being triggered. As I click through this and as I view some of this information, ThreatX also provides you a bunch of different avenues and different ways to kind of slice and dice visually this information. You can filter by attack class, you can look at different max levels, and you can also sort by last seen to help you prioritize what is happening most recent in my environment. From here, the way ThreatX works is we just don't provide the information. We want you to allow your users to deep dive into the details. So as I click into Sweltering Avery, what I can see is a bunch of different metadata that's happening. I can see his IP address again, his location, his user agent. So Nick is actually on Chrome using a Mac. And as I scroll down, I can then see all the different timeline of events that's happening within this specific IP address. If I click into any single one of these events, what I'll see is all the different parameters that we're able to provide, such as what is the full path, what was Nick's full TLS fingerprint, what was his full user agent string, and then again, all the different signatures that were matched. So this was, again, a GraphQL scan detection SQL injection that we saw based upon Nick's activity. Why this is important is because this information can be used, especially when we talk about data correlation or getting this information to the right people or right tools and technologies. The more information, the more data you have, the more power you have to do different things such as investigation and respond. So as you can see here, ThreatX was able to track, identify, and then also block based upon this information, based upon the rule, Nick's Graph SQL injection attack. Now, the next thing I want to do is actually take a look at another different type of dashboard that we have. This is called the API catalog. What we're seeing here is all the different applications or sites that we have that are monitoring this environment. We have different ability for organizations to come here and actually click on certain sites and filter. So for example, this DVGA app that Nick was mentioning before, I can sort by this and just get a view into what's happening specifically with this application or site. From here, I can see all the different types of attack classifications, the total endpoints, and then all the other API profiles in your network. Notice GraphQL right here at the top right, and we see this one count. From here, I'm then able to click into the site itself and then see all different trending and benchmarking that's happening over time. In addition to this, I can also see all the different endpoints that would be listed. Now, in a real production scenario, you would probably have tens, if not hundreds of separate endpoints that would be listed here based upon the application and the site itself. Again, same information you're seeing before. We can profile the different type of API this is. We can then look at what the attack class is, how many threats, and then how many rules and how many block requests are happening, providing you the prioritization again to know what to focus on first. If I click into this GraphQL endpoint, again, what I'm seeing is all different types of detailed information about the traffic trends within this application. But then I also can harness into the information about the specific threats. And then there it is again. You'll see Nick here as Sweltering Avery with his IP address. And the same view before, by clicking into this specific entity, I can get all the detailed information that I want to see. Nick, I'm now going to turn it back over to you to do your second demonstration.
Thanks, Jeremy. I'm excited to get into some more hacking demos here. The second one being a very GraphQL specific attack. As we know, SQL injection is a traditional attack. Let's talk about something new, something GraphQL focused. And why not talk about the 0-day vulnerability that both myself and Dolev uncovered, and it is called directive overloading. So what is a directive? GraphQL provides clients with a way to manipulate how they want their data to be perceived by the server, as well as responded back from the server. So for instance, if I wanted to get all of my fields in a capitalized syntax, I could append the @capitalized directive after the field. So let me show you how that sort of works. As you can see here in Altair, I have my query request on the left, and I have a very simple query, and it's looking for the type name, and it's directly querying the schema of DVGA. Now, to add a directive to a field, as I mentioned, you would just use the @sign followed by some sort of directive that you'd want. Now, GraphQL has a couple of built-in directives, such as skip, but we're not going to include that. We're going to include something random, like AA. Now, if I go ahead and I click send here, you can see that DVGA didn't really like that. Its response back was 400 bad request, and it said here that it doesn't know what the AA directive is. Now, one of the things that we wanted to maybe test out is how many directives can DVGA handle. So let's add a couple more. So as you can see, the more that I add, the larger the response from the server gets. It's actually quite explicit, telling us exactly what directive it's unsure of and what line and column within our GraphQL document it's complaining about. So as you can see, the more directives that I add here, the larger the response. So I'm going to go ahead and copy a really large payload here. And I'm going to go ahead and paste it. Now, this right here causes a denial of service attack against a GraphQL application. Now, the number of directives that we're sending here aren't going to exactly crash DVGA, but cause it to sweat a little bit. Now, the number of directives you add is proportional to the type of resource consumption and CPU consumption that the server would experience when sending the request. You can imagine that if you were to send a really large request with tons of directives, you could potentially even crash the server. So let's go ahead and send this request. As you can see, that took a little bit longer. That took 800 milliseconds there. This type of attack is really hard for a lot of GraphQL implementations to protect against. And we're going to go ahead and send this exact same request against the DVGA environment that's protected by ThreatX here. So let's go ahead and send this request. And as you can see, we have a 403 response, just like we did with the SQL injection attack. Jeremy, do you want to talk about how you blocked this one?
Absolutely. And as expected, again, as Nick mentioned, we stopped him right in his tracks. So the whole goal here of ThreatX is to stop attackers and hackers like Nick from attacking your applications, whether it's directive overloading or other types of GraphQL threat entities and threat types. And so, again, the reason we did that and the reason we were able to block that traffic was acting as that web application firewall in that reverse proxy manner, sitting in front of the application. Again, identifying that Nick was using measures of GraphQL, and then he was going and looking at different types of directives and trying to overpower our system. What I'm going to do now is actually show you into the ThreatX dashboard, kind of that ruling configuration that I mentioned earlier, but what is the logic behind how ThreatX is able to stop some of these attacks? So now I'm going to pivot back to the ThreatX dashboard and show you that rule configuration. Okay, so now we are back at the ThreatX dashboard. And as I mentioned, I want to show you the rules and logic of how ThreatX is able to identify Nick's attacks and then also block those. So what I'm going to do is go into the settings tab here and click on rules. You can see all the different rules that are provided out of the box and some that are also customized for this specific demo tenant. Organizations will have the ability to leverage a lot of the out-of-the-box ThreatX rules, but also be able to customize depending on their industry, depending on the certain types of attacks that they're seeing. For this specific one, we want to look at this GraphQL block directive overloading. If I click on the edit rule details of this, I can view a visualization of how this rule was actually created. But in addition, what we commonly see is individuals and developers creating these rules using JSON formatting. So what I'll see here is the actual logic behind how this rule was triggered. The first thing we're looking for is, does GraphQL, is it contained actually in the URI? From there, we can see a regex match here of all the different directives, for example, or lettering or numbers that Nick was using. Notice here the 5. Any single time Nick went above 5, what we were going to automatically do is apply this rule. From there, we use Boolean logic to say, if this happens, what should we do? Notice the action tab here. We have the ability here at ThreatX to be able to track attackers over time. We can also block them outright, or we can do other types of methods, especially when it comes to bot activity around tar pitting and slowing down the attacker. But notice in this one, based upon the rule JSON logic, we said if this rule is seen and triggered, the action we want to take is go ahead and block. And that's exactly what you saw on Nick's output when you saw the 403 happening here. And what you also saw within the ThreatX dashboard, that Nick's threat actor was blocked.